Hello everyone, I hope you're doing well today. Today we are going to learn how to solve rational equations. We're going to look at two different methods depending on what our equation looks like. One method is going to use what we call as clearing fractions, where we eliminate the denominator. In order to do that, we need to find our least common denominator. So I have three examples here, and we're going to pretend that these values are the denominators of our fractions, or our rational expressions. So let's look at the first one, 2x, 3x squared, and 6x to the third. Well, I know you've worked on finding least common denominators before of numerical expressions, but maybe not polynomial expressions. So when we look at an example like this, where we have all monomial terms, you're going to look at your numbers and variables separately. So if I start off by looking at 2, 3, and 6, their least common multiple, which would be their least common denominator, would be 6, because 6 is a multiple of all three terms. When I look at my variables x, x squared, and x cubed, the least common multiple would be the highest power. So our powers are 1, 2, and 3. My highest power is 3, so my least common denominator would be 6x to the third. Looking at our second and third example, we have binomial factors. In order to figure out what our least common denominator would be if we have binomials, we would first have to factor any of the binomials that can be factored. So if I look at 2x plus 10 and x plus 5, I know I can factor one of them because 2x and 10 have a greatest common factor of 2. So I'm going to take this and factor out the 2 to start with. When I factor out the 2, I'm left with 2 times the quantity of x plus 5. Now I notice that both of my binomials have that x plus 5 portion. My least common denominator is going to have that x plus 5 in it, but it's also going to have this 2 out in front. Whenever we're finding the least common denominator of binomials, you always want to make sure that each piece is included. So if I looked at just the x plus 5, I would think, what is missing from my first denominator? And in that case, it would be the 2. Now moving on to our last example, x minus 2, x plus 2, and x squared minus 4. One of those binomials can be factored. The x squared minus 4 is the difference of squares, so that means that it breaks down into x minus 2 times x plus 2. If I look at all of my terms now, all of my different binomials, I'm going to look at the one that has the most factors, which would be the one that I just factored out. Now if I look at the x minus 2 and the x minus 2 and times the x plus 2, the x minus 2 is missing the x plus 2. If I looked at the x plus 2, it would be missing the x minus 2. I need to account for all of my factors. So when I account for all of my factors, my least common denominator would be the x minus 2 times the x plus 2. Please take a moment to pause this video and record these examples in your notes. Now that we know how to find the least common denominator, let's see how we use it to help us solve rational equations. So if I look at my equation that I have here, 5 over 2x plus 7 over 3x squared equals 1 over 6x cubed. We already found in our previous example our least common denominator of 6x to the third. To get rid of my denominator, or to clear it, I'm going to multiply my entire equation by the least common denominator. So I'm going to take that 6x to the third and multiply each term by it. So if I distribute 6x to the third to 5 over 2x, I'm going to end up with, well, remember my 6x to the third has a denominator of 1. Now to multiply the fractions, I'm going to go straight across. 6x to the third times 5 is 30x to the third over 1 times 2x is 2x. When I simplify this, I divide my 30 by 2 to get 15, and when I divide my variables, I subtract my exponents. So it'd be 3 minus 1, and I'm left with 15x squared. Now when I take my 6x to the third and I distribute it through to the 7 over 3x squared, let's see what happens there. So I have my 6x to the third again over 1 equals, or not equals, sorry, times 7 over 3x squared. When I multiply my numerators, I get 42x to the third over, when I multiply the denominators, 3x squared. When I divide 42 by 3, I'm left with 14, and when I divide x cubed by x squared, I'm left with x. Finally, I need to take my 6x to the third and distribute it to the 1 over 6x to the third. When I put 6x to the third over 1, I can now multiply my fractions, and my multiplication gives me 6x cubed over 6x cubed. Anything divided by itself is equal to 1. If we look at this point now, none of our terms have any denominators, so we have cleared the fractions. They're no longer fractions. I can now use this to rewrite my equation so that I have 15x squared plus 14x equals 1. Please take a moment to pause this video and record our example thus far. Now that I've rewritten my equation as 15x squared plus 14x equals 1, I can solve this quadratic equation. Our first method of trying to solve a quadratic equation should be setting our equation equal to 0, factoring it, and using the zero product property. To set this equation equal to 0, I would have to subtract 1 from both sides of the equation. I get 15x squared plus 14x minus 1 equals 0. Now I'd factor my trinomial using my diamond method. So I'd multiply together a and c, 15 and negative 1 to get negative 15, and my value for b is 14. I want to find values that multiply to negative 15 and add to 14. If I multiply 15 and negative 1, they multiply to negative 15 and add to 14. So that's my pair of numbers that I would use. Then, making my area model, I'm going to put my 15x squared in the top left and my negative 1 in the bottom right. I'm going to fill in the remaining two boxes with the 15x and negative 1x that I found in my diamond. Now looking at each pair of vertical and horizontal set of terms, I'm going to find their greatest common factor. Between 15x squared and negative 1x, the greatest common factor is x. Between 15x and negative 1, the greatest common factor is 1. Between 15x squared and 15x, the greatest common factor is 15x. Between negative 1x and negative 1, the greatest common factor is negative 1 since both terms are negative. If I check out to make sure that all of the individual boxes have the correct area by multiplying, I will know that I factored it correctly. If I look at the 15x and the x and multiply them, they give me 15x squared. That checks out. If I multiply 15x by 1 is 15x. That checks out. If I multiply negative 1 by x, it gives me negative 1x. That checks out. If I multiply negative 1 by 1, that gives me negative 1, so that also checks out. So now I know my equation factors into x plus 1 times 15x minus 1, and it's equal to 0. To finish solving this equation using the zero product property, I'm going to set each factor equal to 0 and solve. So if I have x plus 1 equal to 0, x is equal to negative 1. If 15x minus 1 is equal to 0, that means 15x equals 1, and x equals 1 over 15. So my two solutions to this equation are negative 1 and 1/15. Please take a moment to pause this video and finish recording this example in your notes. Now let's take a look at another example. We've already found our least common denominator of 2 times the quantity of x plus 5. So I'm going to take each term and multiply it by my least common denominator. Okay, so if I take my x plus 3 over 2x plus 10 and multiply it by 2 times x plus 5 all over 1, I'm going to first cancel out any common factors. Well, if I distribute out the 2 through the 2x plus 5, that gives me 2x plus 10. So the 2x plus 10 cancels out, and I'm left with x plus 3 over 1, or just x plus 3. Now I'm going to take my second term, 3x plus 1, over x plus 5, and also multiply it by the 2 times x plus 5 over 1. I notice that my denominator here and the numerator here both have a factor of x plus 5, which means the x plus 5 cancels out. Now I'm left with 3x plus 1 times 2, or 6x plus 2, over 1, or simply just 6x plus 2. Now if I take my final term, x over x plus 5, and I multiply it by the 2 times x plus 5 over 1, I notice again that I have x plus 5 in this denominator and x plus 5 in this numerator. Using cross-canceling, those cancel out, and I'm left with x times 2, or 2x, over 1, which is simply just 2x. Now I can rewrite my equation as x plus 3 minus the quantity of 6x plus 2 equals 2x. Please take a moment to pause this video and record this example thus far in your notes. Now that I've rewritten my equation as x plus 3 minus the quantity of 6x plus 2 equals 2x, I can solve it by first simplifying and taking the negative and distributing it through the set of parentheses. So I get x plus 3 minus 6x minus 2 equals 2x. I can simplify it further by combining my like terms. X minus 6x gives me negative 5x, and 3 and negative 2 gives me 1. Now to solve this linear equation, I would add 5x to both sides and get 1 equals 7x, and then divide by 7 to get x equals 1/7. Please take a moment to pause this video and finish recording the example in your notes. Before moving on to our second method of solving a rational expression, let's look at one more example. Now, we found our common denominator in the first set of examples. So now I need to take my equation and multiply it by my common denominator. So let's multiply each term by the common denominator. So I'm going to start off by multiplying x minus 1 over x minus 2 by x minus 2 times x plus 2, and remember, I always put it over 1. The first thing I'm going to do is see if I can cross cancel. I have an x minus 2 in this denominator and an x minus 2 in this denominator, which means those cancel out. So now I'm left with, in my numerator, x minus 1 times x plus 2, and my denominator is just 1, so I don't need to show that. When I distribute this out, I end up with x squared plus x minus 2. Now I'm going to look at my second term, 2 over x plus 2, and I'm going to multiply that by the x minus 2 times x plus 2. And remember, my denominator is 1. Looking at my denominator here, I have an x plus 2. In this numerator, I have an x plus 2. I can use cross-canceling to cancel those out, and I'm left with 2x times quantity of x minus 2 over 1, or just 2x times x minus 2. When I distribute through the 2x, I get 2x squared minus 4x. Please take a moment and pause this video and record our example thus far. X squared plus x minus 2 plus 2x squared minus 4x. Now I need to take my last term, 4 over x squared minus 4, and also multiply it by my common denominator. Remember, the common denominator was x plus 2 times x minus 2. I'm going to place that over 1. Now I'm going to factor my denominator of x squared minus 4. So I have 4 over x plus 2 times x minus 2 times x plus 2 times x minus 2 over 1. If I look, my denominator here is exactly the same as the numerator here, which means they completely cancel each other out. That means that the only thing I'm left with is my numerator 4 and denominator 1. 4 over 1, or just simply 4. Now I can take what I have done and rewrite my equation as equals 4. Please take a moment to pause this video and record this next step of our example in it. Now that I've eliminated my denominators, I can simplify my equation and solve it. I'm going to start off simplifying by combining my like terms. X squared and 2x squared combine to become 3x squared. X and negative 4x become negative 3x. Negative minus 2 equals 4. Now that I've combined like terms, I'm going to set my equation equal to 0 by subtracting 4. So I get 3x squared minus 3x minus 6 equals 0. Now I can factor my trinomial using the diamond method and solve with the zero product property. But before I factor with the diamond method, I notice that all three terms have a common factor of 3. So I'm going to pull out that 3, and I would have 3 times the quantity of x squared minus x minus 2 equals 0. I would now factor the trinomial x squared minus x minus 2 using my diamond method. So finding factors of a times c, 1 times negative 2, that sum to my value of b, negative 1. Numbers that multiply to negative 2 and add to negative 1 are negative 2 and 1. Creating my area model, I'm going to put my x squared in the top left-hand box and my negative 2 in the bottom. My remaining two boxes are going to be filled out with the negative 2x and 1x that I found in my diamond. Now I'm going to look at the greatest common factors of each vertical and horizontal pair of numbers. Between x squared and 1x, my greatest common factor is x. Between negative 2x and negative 2, my greatest common factor is negative 2. Between x squared and negative 2x, my greatest common factor is x. And between 1x and negative 2, my greatest common factor is 1. Which means x squared minus x minus 2 factors into x minus 2 times x plus 1. And I know my equation is set equal to 0. Now if I set each factor equal to 0 and solve, I will have finished solving my equation. So if I set x minus 2 equal to 0, x is equal to 2. If I set x plus 1 equal to 0, x is equal to negative 1. Now I have finished solving my equation and I have two solutions. X is equal to 2 and x is equal to negative 1. Now sometimes when we solve these equations we end up with what's known as extraneous solutions. Let's see if we have any extraneous solutions. So we solved our equation and we got that x equals 2 and x equals negative 1. Well, one thing that I need to do is when I get to the end of these problems is check to make sure that when I plug in any of these values, I don't get a denominator of 0. Remember, division by 0 is undefined. If I look at my first term, x minus 1 over x minus 2, when I plug in my value of 2 for x, I end up with 2 minus 2, which is 0, which means I would have division by 0, which again is undefined. Therefore, I cannot have an x value of 2. So 2 is an extraneous or extra solution that does not work. The only solution to this equation is x equals negative 1. Please take a moment to pause this video and record the last step of this example in your notes. Now, the other method of solving a rational expression is probably something that's a little bit more familiar to you that you might remember doing from Algebra 1 or middle school. When we have a rational expression equal to a rational expression, we really have a proportion. When we solve proportions, their cross products are equal. So I can just take my 2 and x and multiply them to get 2x, and my 5 and x minus 8 and multiply them to get 5x minus 40. Now I said my cross products were equal, so I can set 2x equal to 5x minus 40 and solve. To solve this equation, I would first subtract 5x from both sides and get negative 3x equals negative 40. To solve now, I would just divide both sides of my equation by negative 3 and get x equals 40 over 3. Now looking at our second example, I would start off with my cross multiplication and multiply 2x minus 3 by x minus 1. When I use my double distributive property, I would multiply 2x by x to get 2x squared, 2x by negative 1 to get negative 2x, and negative 3 by x to get negative 3x, combine them to get negative 5x, and then multiply negative 3 times negative 1 to get plus 3. Then I would multiply my 4x by x to get 4x squared. And I would have set my cross products equal to each other and have the equation 2x squared minus 5x plus 3 equals 4x squared. Now since I have a quadratic equation, I would set it equal to 0 and factor and solve with the zero product property. So by subtracting 4x from each side of the equation, I get negative 2x squared minus 5x plus 3 equals 0. Since I never want to have a negative leading coefficient, I'm going to factor out a negative 1. So I have negative 1 times 2x squared plus 5x minus 3 equals 0. factoring my trinomial 2x squared plus 5x minus 3 using the diamond method, I would end up getting 2x minus 1 times x plus 3. And my equation again is equal to 0. Now if I set each factor equal to 0, if I have 2x minus 1 equals 0, that means that 2x is equal to 1, which means x equals 1/2. If I set x plus 3 equal to 0, x is equal to negative 3. Now if I look, I can plug in both 1/2 and negative 3 and not get a denominator of 0 in either of my rational expressions. Therefore, there are no extraneous solutions here. Please take a moment to pause this video, record these examples in your notes, as well as any questions that you may have on solving rational equations. Take care, stay safe, and be well. I'll see you in the Zoom meeting shortly.